Hey everyone, this is Nadeem and welcome to my YouTube channel. Today we will demonstrate about the AC through capacitor. So here we have this device, and in this device we have the plates inside it, and if we provide the potential difference to this, okay, if I connect this with the battery, okay, the current will flow from from this terminal. Okay, let's say this is the negative terminal of the battery and this is the positive terminal of the battery. The charges will flow from this negative terminal, and here inside this device we have the plate on this side, and that plate will become the negatively charged, and this on this side the plate will become positively charged. Okay, so now it has charged. Okay, so the charge is stored in this device. Now if I connect the this LED bulb with this, okay, and it will glow up. Okay, so focus on this, it has glow, and now it is turned off. Even I connected these two terminals. Okay, so the physics behind this is that if we have that device, if we connect that device, inside that device we have the two plates. Okay, and if we connect that with the DC supply, here we have the DC, this is the negative, this is the positive terminal of the DC, and if we connect that with these plates, okay, so this plate will be negatively charged, this above plates will be negatively charged. Large number of negative charge will appear on this plate and large number of positive charges will appear on these plates. Okay, so here the electric field will develop inside these between these two plates, and that electric field line will be from this positive towards the negative, and here in between these two plates we have large number of electric field lines which originate from the positive charge and will terminate on the negative charges. So even if I remove this battery, the charges will still present on these plates due to this electric field present between these two plates. Okay, so if I remove this, okay, and I connect here, I'm going to, and this is one plate, this is the other plate, and this is their terminal. Okay, and this is that other wire, and here I have removed this battery, and instead of this battery I connect the LED bulb here. Okay, this is the LED bulb. So this was that scenario, and here we have that negative charge present on this plate and the positive charge is present on this plate. These now this behave as a battery. Okay, so this is the negative terminal of the battery, this is the positive terminal of the battery, and these charges will start motion here, and for that small instant this bulb will glow. Okay, this bulb will be glow, and after that it will off. Okay, so because here these charges will be neutralized, and there is no reaction occur inside it, because this is not a battery, this is actually a capacitor. In battery we have the chemical reaction, it will produce the EMF. So here is no source of EMF, so this is actually the capacitor. Okay, so for that small instant this bulb will be on. Okay, so after that small instant this will be neutral, these plates will be neutral. Okay, even so this neutral plates, if I connect with that same LED, then there will be no the current will pass through that, and there will be no current, and this will be not glow up. Okay, so this was that case. Okay, so here we have that device. If I connect in this first scenario, if I connect this device with this a DC, okay, if I connect this, so the positive charge will appear on one plate and the negative will appear on the other if I connect with the battery. So now I remove the battery. So now this is the case. Okay, now I remove the battery and I'm going to connect. Here I have removed the battery, and instead of the battery I am going to put the bulb. Okay, so here I am going to put the bulb, and this bulb will be on for a small interval. Okay, it has on and now it has off. So this is the second condition, and in third condition, now this has discharged. Okay, so if this is discharged and I connect the bulb, it will not glow up. Okay, so this is the behavior of the capacitor to DC. Now what will happen if I connect this with the AC? Okay, so for that I have this device, which is actually the step down transformer, which work on the AC. This is actually the AC source for me. Okay, and I am going to connect this device, this transformer, with the AC. Okay, here I provide the 220 volt, and this transformer convert that into these 3 volt, 6 volt, 9 volt, and 12 volt. Okay, so here now the supply actually here I am going to connect this capacitor with this AC. Okay, so this is the 0 terminal and this is the 3 volt, so this will be here, it has charged. Okay, and now I connect the same thing. So here the physics behind this in this case is this. Okay, so now I have connected, in this case I have connected the AC supply. Okay, this is the AC supply, and if I connect that with one plate and the other terminal with the other plate, so this is actually the one plate and this is the other plate. Okay, here this polarity is changing. Okay, this is alternating current. The direction of the alternating current is changing. So for small instant, this side will be positive, this will be negative. So here this plate will be positive charge. Okay, these plates will be positive charge, and for that small instant, infinite small, very small instant, this side will be negative. And here we know this AC supply is changing its direction. Now it's changed its direction, and this become the positive and this become the negative. Okay, now in this case the negative charge will flow toward this side, and these charges will be neutralized due to this negative charge. Okay, and here this positive charge will go and will neutralize this. Okay, so now on the other cycle this will become positive and this will be the negative. So up to here this has neutralized. Okay, so again the charges will go and the positive charges will appear on this plate and the negative charge will appear on this side, on this plate. And if again this polarity is changed, this become positive and this become negative, again the discharging of this capacitor will be occur. So from here we conclude that when this become the positive and this become the negative, here the capacitor will be charged. Okay, so if it change its polarity and this become the negative and this become the positive, the negative charges will flow here, and these charges will be neutralized due to that negative charges, and now the capacitor has discharged. So for one cycle this capacitor will be charged For the other cycle, this capacitor will be discharged. Okay, so for the other cycle, this capacitor will be discharged. Okay, so here in case of the DC, if we provide the DC, okay, this capacitor will be only charged. Okay, so if we provide the AC, this capacitor will be charging and discharging about 50 times in a second, because the frequency here in our country is about 50 hertz. So this charging and discharging will occur 50 times in a second. So this is the behavior of the capacitor with the DC supply and the AC supply. So the last question here is that what will happen if I connect here the bulb? Okay, just like in the previous case. Okay, so in the previous case we connected the bulb here. Okay, so here now what will happen if I connect the bulb here? Okay, so in this case this bulb has glow for small time, for small interval, because that electron will flow from this negative charge, okay, a negative plate. Okay, and during that motion this bulb will be on, but here the number of the negative charges will be more on this plate. Okay, due to which this potential and this potential will be same, and here the current will be stopped and this will be stopped. This will be turned off. Okay, so it means that if we have the capacitor and along with that we have this bulb, and if we connect that both with this DC supply, this bulb will be on for a small time. Okay, then after that it will be turned off. So here we have that same scenario. Okay, so this is that case. This is actually the capacitor. Okay, this is actually the bulb here. This is the bulb. Okay, this is the bulb, and now I am going to connect. So this is actually the capacitor, this is the bulb, and now I am going to connect these two with the battery. Okay, so I have the battery, I have this battery, and I am going to connect these. So you will have to focus on the bulb. Okay, so if I connect this, okay, if I connect this bulb has on for a small interval. Okay, for a small time. Okay, so this is because the charges will flow for that small interval, and here the charges will be more, and due to which that current will be stopped due to the same potential difference here, the zero potential difference here. So this will be stopped and no current will be flow. So what will happen in this case? What will happen? Okay, so for that I will have this capacitor. Okay, this is actually the capacitor, the same scenario. This is the capacitor. Here we will have this bulb, attached with this terminal. Okay, and the other terminal of this bulb will attach with the AC supply. Okay, and this terminal, these both terminal we will apply with we will attach with the AC supply. So here this bulb have very small voltage, so therefore I don't connect this with the AC supply. So therefore I don't connect this with this. So what will happen in that case? So in that case, here the negative, this side for that small interval will be negative, and that negative charges will flow here, and this side will be the negative. Okay, and this side will become the positive. Okay, so here in this case the electron inside this conductor will flow in this direction. Okay, now if this polarity has changed and this become the positive and this become the negative, this negative charges will flow here, okay, and it will neutralize this, and similarly here this positive charge will flow here. Okay, now this direction has changed, so this electron will move in this direction in this case. Okay, so if the polarity again change, this become negative, this become positive, again that electron will move in this direction, and if this polarity is changed, that electron will move in this direction, and this way each electron inside this conductor will be vibrating around their mean position, about their mean position. Okay, so here is the concept of the alternating current is still present. Okay, so this bulb will be on forever, this bulb will be on. Okay, in that case that bulb was on for a small interval, but in this case if we provide the alternating source, this bulb will be on for a long time until we provide this source, this AC source. So from here we conclude that that this DC capacitor will block DC current, and this capacitor will allow AC current. So this is the this is the conclusion of this. Now we will derive the expression for this, and the final expression of Xc will be equal to 1 over 2 pi f into C. Okay, so in this case if we put, so the frequency of this DC is equal to 0, so for the DC frequency is equal to 0. Okay, so therefore this Xc will be equal to 1 over 0, and 1 over 0 is equal to infinity. This resistance will be infinite here. Okay, so the resistance will be infinite and the current will not flow, and here this will be turned off. So this is the physics behind that, and now I am going to derive the expression, and I am going to also criticize the reason behind why the voltage is lags behind the current, and we will derive the expression for that, and also for the power, and also derive this expression. So let's start that. Here we have that same scenario in which the alternating voltage is connected with the capacitor, and when this is alternating source, this capacitor will be charged and discharged, and here if we connect the bulb, that will be glow. Okay, so still the capacitor is charging and discharging, but still here the electron is vibrating about their mean position, and the criteria for this bulb is actually the vibration of electron. Okay, so it do not care about what is happening in the circuit, but here is the minimum criteria is actually the vibration of electrons. So here the electron is vibrating about their mean position, so therefore it will be glow up. But in case of the DC, okay, this will be off, because here that electron will be flow here. Let's say this side become positive in case of DC, and this negative, this plate will become positive. Okay, here the potential will be more as compared to this. So here if the potential difference is 0, then no current will be flowing in this conductor. In that case the this bulb will be off. Okay, so let's here for the instantaneous value for this alternating voltage is given by V is equal to Vm sine omega t. Okay, so due to this alternating voltage, the capacitor will here the potential difference will be developed between the plates of the capacitor, and the charges will be appear on the plates, and here it will have some capacitance, and from the formula of the capacitance, the Q is equal to CV. This is the charge on the plates of the capacitor. This is the potential between the plates of the capacitor, and this is the capacitance of the capacitor. So here if we multiply del by del t on both sides of this equation become del q by del t is equal to c del v by del t. Okay, the difference between these two equations is actually only the difference between is only del by del t. So here in this side we have del by dt, and in this side we have del by dt, and these three things are comes in its own position. So here we know that the change in the charge mean that the number of the charges passed through a given area per unit time is called the current. So instead of this I can put the current, and which is equal to C and del, and instead of this V we will put this value which is equal to Vm sine omega t and divided by del t. Okay, so we have to rearrange this. So this will become I is equal to C Vm del by del t of sine omega t. If we apply the calculus here, the differentiation of the sine theta will be the cos theta, and therefore we can put here is that Cvm sine, so this sine will be converted into cos omega t del omega t divided by del t, and if we simplify this further, I is equal to Cvm cos omega t, and it will be equal to omega. So I is equal to from here I is equal to Cvm omega cos omega t. Okay, so these three things is equal to Im. So instead of this C Vm omega I will put Im. So this equation, this above equation will become I is equal to Im cos omega t. Okay, so cos omega t is actually the leading the sine function by 90. So therefore instead of this we can put Im sine omega t plus 5 by 2. Okay, so this is the equation 2 and this is equation 1. So from equation 1 and equation 2 we can conclude that this potential is actually is a function of the sine. Okay, so this is this voltage, alternating voltage is a function of the sine, and here this current is also is a function of the sine. So for both we have the same what we can say the same graph. Okay, but here this current is leading by 5 by 2. Okay, so therefore here this is actually, this difference is actually 90 degree, which is equal to 5 by 2. So here only the difference is that this current is start from here. Okay, and that is leading this voltage by 5 by 2. Okay, this is leading by 5 by 2 here. Okay, so this is the contextual meaning of this equation 1 and equation 2. Now what will be the power here? Okay, so for the power we know that power is equal to power for the power we know that P is equal to I and V. So here I is equal to Im cos omega t, Im cos omega t, and this v is equal to Vm sin omega t, Vm sin omega t. Okay, so from here we can put this Im Vm cos omega t multiply sin omega t. If we multiply cos omega and sin omega t, it will give us the zero value, so it will become this. Okay, Im Vm into 0, and it is equal to 0, so the power in this case is 0. Why from this 0? So this is the graphical explanation for that. Okay, so here this is actually the current. Okay, this is the current, and which leading the voltage here. Okay, so here in this quadrant, the value of the current is positive, and similarly the value of the voltage is positive. If we multiply positive with positive, it will give us the positive value, and here the power is maximum. Okay, and similarly here this voltage is negative and the current is positive. If we multiply negative with positive, the answer will be the negative, and this is the power. Okay, this shaded region is the power, and with the negative sign. Okay, this is here both are the negative, the current is negative and the voltage is negative, so therefore the power is positive. Okay, and in this case we have the voltage is positive and the current is negative, so therefore if we multiply positive with negative, the answer will be the negative, and this is for the power. Okay, so now in the last section of this video, I am going to find the capacitive reactance, and which is given by capacitive reactance, and which is denoted by let's say Xc. Okay, and this is actually analogous to the resistance of the Ohm law. V is equal to I R. So here if I put instead of this R as Xc, so this equation will be modified as V is equal to let's say this is Vm is equal to Im Xc. So from here Xc is given by Vm by Im, and instead of this Vm we will have to put, instead of this Im we will have to put this value, which is equal to CVm omega. Okay, so this Vm is come in its own position, so here CVm into omega, and this Vm and Vm will be cancelled, which is equal to Xc is equal to 1 over C omega, and instead of this omega we will put 2 pi f into C. Okay, so this is the relation for the inductive reactance, which is equal to 1 over 2 pi f into C. Okay, so this relation for the DC is given. For the DC, the frequency is 0. Okay, so this relation will become this Xc is equal to 1 over 0, and which is equal to infinity. So this resistance, this reactance, capacitive reactance will be infinite for the DC. Okay, so therefore the DC will block that alternating current. Okay, and it will allow the here this capacitor will block the DC current, and it will allow the AC current. Okay, so this was the explanation about the alternating current through capacitor. First I have demonstrated that, and this is the mathematical interpretation of that, and this is actually the phasor diagram for that, and this all is from my side, and I think you got my points, and that's it guys. Thanks for watching.